Okay, today is Wednesday, October 9th, correct? 9th? I think it's the 9th anyway. But it's a Wednesday. And we have 4 warm-up questions from section 3.2 in our MathLinks 9 book on exponential rules. We have 6 laws that we learn. And most of them, I think, are here in these 4 questions, but we'll see. The first question gives us 2 times 10 times 2 to the 4th divided by 2 to the 12th. So what we really have is just a BEDMAS question using exponents. So the first thing I'm going to do is think about what can I simplify that to as a power. And of course, law 1 says when you're multiplying 2 powers together that have the same base, you can keep the base. And add the exponents, which would give us this. And then now that we look at the next part, it's 2 to the 14th divided by 2 to the 12th. Since we have the same base, 2 powers with the same base, the law is you can keep the base and subtract your exponent. So 14 take away 12 is 2. And therefore, in standard form, when I simplify that using sign rules, I would end up with 2 to the exponent of 2. And if you went one step further and put it in standard form, you have the answer of 4. In the second question, we have 2 cubed squared. Remembering what this would be, and this is not what you write, but 2 cubed squared means 2 cubed multiplied by itself twice, which if I look at it that way and use law 1, we know that that's going to be 2 to the 6th, right, to the exponent of 6. But the law is actually when you have a power to an exponent, the rule says keep your base and multiply your exponents. So 3 times 2 will be 6. Same thing with this one. We have a power to an exponent. So keep your base and multiply your exponents. You're going to get 12. Now that we've simplified that part, we now have 2 to the 6th multiplied by 2 to the 10th. Using sign rule number 1, our rule is keep the base and add your exponents. So our final answer as a power would be 2 to the exponent of 18, which is a pretty big number. 2 multiplied by itself, 2, 4, 8, 16, 32. That's like a classic exponential growth amount. So 2 to the exponent of 18 is 262,144 in standard form. Our next one deals with exponent law 6, where we have powers to the exponent of 1 and 0. The first one, if I look at this one, can anyone tell me what that says? Anybody want to read it for me? Go ahead, Sophie. Say it again. Yeah, but what does it say? What does it? If I wanted to read that, what would I read? Right, the opposite of 4 to the exponent of 0. It is not negative 4 to the exponent of 0, because that's what this says. This says negative 4 to the exponent of 0. But the first one says the opposite of 4 to the 0. And we know that because there's, again, don't want to sound like a broken record, but there's no brackets around the base, therefore the base is not. So since 4 to the 0, or any base to the exponent of 0, is 1, the opposite of that will be negative 1. And here in the second one, we do have negative 4 to the exponent of 0, and any base to the exponent of 0 is a positive 1. So I'm going to write down positive 1. Plus, any base to the exponent of 1 is what number? The base itself. So negative 4 to the exponent of 1 will be negative 4. So when I simplify my exponents, I get this. Negative 1 plus positive 1 is simply 0, plus negative 4, by simplification, will be negative 4. And finally, our last warm-up question gives us a product of 2 numbers in brackets to an exponent outside the brackets. And the rule is you could do it one of 2 ways. You could solve it with BEDMAS. 3 times 4 is 12. And 12 cubed is 12 times 12 times 12, or 144 times 12, which I can't do in my head, is 1,728. But using sign rules, we can allocate this 3 to both parts of our product. Meaning, we can rewrite it as 3 cubed multiplied by 4 cubed in exponential form, or 27 times 64. Anyone want to guess what 27 times 64 is? It is, yeah. 27 times 64 is 1,728. So the expectation for this one is you understood that because it was a multiplication of 2 numbers or more numbers, it doesn't have to be 2, it can be more than 2, to an exponent, we can rewrite it like this, as 2 powers, and then simplify it from there. Or, alternatively, and probably more simply, we could simply solve it using BEDMAS, multiply our 2 numbers together, and get our standard form.